Morning students. Let me start with electric potential energy and we'll do the work done by dipole also. So electric potential energy. What is electric potential energy? We say when the test charge is moved in electric field from one point to another point against the force exerted on it by the field, the work done by some external agent moving a charge is acquired by the charge as potential energy. When I say potential energy, this electric potential energy is conservative. That means it does not depend on the path followed by the charges. It only depends upon the position of the charges in electric field. So here I will take Q1 charge positive at point A. I have taken a point B here. Initially, I have taken a test charge, we can say a positive charge Q2 at point infinity. So let's find out the potential at point B, potential V at a point B due to Q1. So I have taken AB, distance of this AB is, let's take, it is R. So I can write potential V is equal to 1 upon 4 pi epsilon naught Q1 upon R volt. Right? Now what I'm going to do, I'm going to bring this charge Q2 from infinity to this point B. Now when I'm bringing a charge from infinity to a point B, I am performing some work, and that work is known as W is equal to Q2 V. I'll put the value W is equal to 1 upon 4 pi epsilon naught. It becomes Q1 Q2 upon R joule. This work done is in terms of, is known as electric potential energy. It's known as electric potential energy, and we symbolize this as U is equal to 1 upon 4 pi epsilon naught. It's Q1 Q2 upon R joule. Remember this formula. You apply this formula when there are two charges. Suppose there are three charges. Let's take, if there are three charges, I'll take a triangle at the vertices. Let's take Q1, Q2, 3. Please note. Let's take, I have drawn a triangle here. This is A, this is B, this is C. Q1 charge, it's Q2 charge, and Q3 charge. The distance of A and B is R12. Distance of Q2 and Q3 is R23, and distance of A from C is R13. It forms triangle. It may be in any form. It may be a square also. It may be a rhombus also. Now this form, more than two charges form a system. Let us find out the electric potential energy of this system. So we say electric potential energy is given by, now I'll write capital U is equal to 1 upon 4 pi epsilon naught. Let's do these two. I'll take these two charges first. I'll get Q1, Q2, distance is R12 plus 1 upon 4 pi epsilon naught. I'll take these two charges now. Q2, Q3 upon R23 plus, now I'll take these two charges. 1 upon 4 pi epsilon naught. It's Q1, Q3 upon R13. I may even write this as U is equal to 1 upon 4 pi epsilon naught. I'll take common. Inside you will get Q1, Q2 upon R12 plus Q2, Q3 upon R23 plus Q1, Q3 upon R13. I'll get this formula. So if in a numerical, the value of Q1, Q2, Q3 are given, the distance R12, R23 and R13 is given, you put the value, substitute the value in this formula and you will get the answer. But remember, you must be knowing the value of this is 9 into 10 to the power 9 Newton meter square per coulomb square. You must remember the value of this. It's important. Is it okay? Let's take an example. I'll take a triangle plus Q plus 2Q plus 4Q. A are the distance of the charges. All sides of a triangle are same, right? I can give the values now. Let's take, if Q is 150 nanocoulomb, I have taken a charge nanocoulomb, and I can take small r is equal to 0.12 meter, right? These two are value, and we have to find the electric potential energy of this system. So what I'm going to do, using U is equal to 1 upon 4 pi epsilon naught. Now, I have taken this common. You can see, I can write here Q1 into 4Q2, so 4Q, Q into 4Q upon A square upon A plus, in दोनों का you'll get 4Q into 2Q upon A plus, now these two, Q into 2Q upon A. Solve. U is equal to 1 upon 4 pi epsilon naught. In bracket, you'll get 4Q square upon A plus 8Q square upon A plus 2Q square upon A. Solve. U is equal to 1 upon 4 pi epsilon naught. In bracket, LCM will be A, and you will get 4 plus 8 is 12, 12 plus 2 is 14, it's 14Q square. Now I can put the values here. You know, the values are like this. U is equal to 9 into 10 to the power 9, bracket 14 into the charge. Charge is about 150 into 10 to the power minus 9. It's nanocoulomb. Nano, 10 to the power minus 9 meters. Whole square. Divide by A. What is A here? 0.12 meter. Right? And when you solve this, you will get, I've used calculator, you will get U is equal to 9 into 10 to the power 9, within bracket, you will get 150 into 10 to the power minus 9 into 150 into 10 to the power minus 9 into 14. You will get this, divide by 0.12. You will get 2.625 into 10 to the power minus 12. U is equal to, multiply this with 9 into 10 to the power 9. You will get 0.023625 joules. That becomes U is equal to 0.0236 joules. So this will be the electric potential energy of the system. Now the charges, these charges I have taken all positive. The charges might be negative. One of the charges might be negative, another two may be positive, or two may be negative, one can be positive. So this is the process you will be doing. Okay? Thank you. Iske baad I'll do in the next topic. Thank you.